Good. So the distance is 133.3. What's the last question? What's the last question? Yeah, it's Kelly.
Yeah, please, when you use the graph, you will get 133. So is it still correct?
Oh, because all along we've been approximating our values. Look at, okay, look at the time. It is an approximated value. 6.7 is an approximated value. So that's the reason why we are not getting a precise, but that's slight difference. Are you okay?
Yes, please.
Okay. So what's the last question under this? Please let's hurry up with the response so we could. Okay, time taken by the body to move from X to M. We have calculated that, and that is 13.3 seconds. So that's the solution to the weekend challenge. Okay. I today forwarded 2 questions, okay, on our group. Please let's go back and then quickly check. I forwarded 2 questions. So let's look at the third question. Are we there?
Yes, please.
Good.
Yes.
So is that a ball is thrown? Please, because I've forwarded it to the group, I'm going through it quickly. Okay, so a ball is thrown upward from the top of a building with an initial velocity v not equal to 20 meters per second. The building is 40 meter high. Taking J to be 10 meters per second squared and neglecting air resistance, find A, the time T1 for the ball to reach its highest point. B, how high will it rise? C, how long will it take to return to its starting point? D, the velocity V2 of the ball at this instant. And finally, the velocity V1 just before the body hits the ground and the total time of flight. I want you to attempt A to C. Okay, A to C. The D and the E, I have to come in. So I'm giving you 5 minutes to go through A to C. Please, are you okay? Are we fine?
Yes, please.
All right. So your challenge starts now. A to C. 3 minutes. 3 minutes more. So from the ground level, okay, and an object is projected from the top just to the maximum height or the highest point, and then comes back. Okay, so the height from the ground to the apex of the tower is equal to 40 meters. Now the initial velocity of projection or the velocity of projection we are given as V naught is equal to 20 meters per second. Okay. The first question, if we are also given gravity G, 10 meters per second squared. The first question demands that find the time T1 for the ball to reach its maximum, its highest point. So we are looking for T1. Okay, so T1, what is the time taken for the body to reach its highest point or maximum height? Certainly would be either be equal to U on G, or when you use the first equation of motion, V is equal to U minus GT. Knowing that at the maximum height, the final velocity is 0. When you substitute 0 for this, and then initial velocity 20 minus acceleration due to gravity was given to us as 10 meters per second squared T. Therefore, time T would be equal to 20, making T the subject we have T to be equal to 2 seconds. Okay, or if we want to use the formula straight away, U is 20, J is 10, this is equal to 2 seconds. Let me see those of you who got this correct. I'm counting. Okay. Okay. All right. The rest of you, please, those of you who couldn't get that, please, there's the solution. Okay. This is a simple question to solve. All right. Let's put our hands down. The second question. The second question, B. How high will it rise? Abba Busha, are you there? Abba,
Yes, sir.
did you get the first one correct?
No, please.
So I think it is clear to you now.
Yes.
Is it? All right. So how high will it rise? And this question talks about the maximum height or distance traveled by the body when projected from the top of the building. Okay, so the standard formula has it that maximum height, H max, is equal to U squared over 2g. U squared over 2g. Or when you use v squared is equal to u squared minus 2jh. When you substitute at maximum height, final velocity is 0. So 0 is equal to 20 squared minus 2 times j, which is 10 times h. H is what we are looking for. So 20h is equal to 20 squared, which is 20 by 20. Therefore, h is equal to 20 by 20 divided by another 20. And sometimes I personally love solving some of this question without using calculator. And look at how clearer it is. Okay, so you can just cancel out to get your value. 20 meter. If you want to use a standard formula, okay, h would be equal to u squared on 2g. Therefore, 20 squared over 2 times 10 would also give you 20 meter. Let me see by hands, those of you who got this right. 5. Oh, only 13 of you. 14. Okay. All right. If you didn't know, now you know. Any question to this particular problem or part of the question? If you have any question, you can quickly ask. Okay, go ahead. Stephanie, Gloria, go ahead. Let's have Stephanie first. Oh, okay. Then the third question. How long will it take to return to its starting point? How long will it take to return to its starting point? Yes. Lizzie, what did you get? Addison, Lizzie Addison, what did you get for this particular question?
Please, I just got the question, so I'm now doing it.
Okay. Stephanie, what did you get?
I got 4 seconds.
Then who else? Bushra, what did you also get? Okay, so the body is projected from this point. Okay, it will go. Let me adjust the screen. It will move from this point, get to the maximum height, and then start. So this is the highest point or the maximum height. And they are asking how long will it take to return to its starting point? It will go get to the maximum height and then, so it will take the same time taken by the body to move from the point of throw to the maximum height and then return from the maximum height to that same point. So if it took 2 seconds to move from here to here, it will also take the same seconds to get to this level. So C would be 4 seconds. C, the C part of the question will be 4 seconds. If you want to, Kelly.
Ms. Idia, please, for upward acceleration, upward motions acceleration, isn't it normally negative 10 meters per second?
Yes.
But the question gave it in positive. So does that mean that when the question gives it in positive, you should just use it?
Kelly, that is why in our equation of motion, we are using negative. We factored that. into it already. That's why, because the body is moving up, that is why it is from positive to negative. So if you've been observant, in all our equations of motion for vertically upward motion and gravity, we have minus, minus, minus. Are you okay?
Okay, sir, please, thank
Oh.
you.
So we took that into consideration. Okay. All right. Can we continue? Then the next part of the question, the D part is the velocity V2 of the ball at this instant. And what is the instant here? The instant here refers to the ball returning to a starting point. So the question demands the velocity there. Okay. Let me take the question again. The velocity V2 of the ball at this instant. Okay. So it refers to the previous question, the instant where the ball returns to its starting point. Now, when it gets to the maximum height and it is returning, okay, when it's dropping downwards, it's a free fall. It's a free fall. And in free falling, okay, in free falling, we are saying that it is when force of gravity is the only force acting on the body. So if you recall, we derived equations for free falling. And the first one, U plus GT. But because when a body is free falling, the initial velocity is equal to 0, we have V is equal to GT. The second one would be V squared is equal to U squared plus 2AS. U is 0, so we have V is equal to square root of 2A by X. Kelly, are you there?
Yes, please.
Kelly, observe something. You see, in this particular consideration, the body is falling back to the ground or to the earth. Okay, and so because we are moving, the body is moving vertically downwards. Look at gravity. Gravity G becomes positive. The body would accelerate due to gravity. That's why we have plus. Are you okay?
Yes, please.
So that further explains your concern. So the velocity there will be V is equal to G. G is 10. What is the time taken for the body to move from the maximum height to the point where it is initially thrown? What's the time? Yes, class, what's the time taken for the body to move up there to the point where it is initial? Come again. Hello, I'm listening. What's the time?
2 seconds.
So that's 2 seconds. So 2. Therefore, the velocity at that instant will be 20 meters per second. So it leaves the point of projection with the velocity of, yes, it leaves the point of projection with the velocity of 20 meters per second. By the time it gets to the same point, it has the same velocity as when it was initially projected. Please, are we okay? Are we okay?
Yes,
We can also use this equation V to calculate the same value of V. And that is 2 times gravity 10 by, what is the What is the height or the distance from the maximum point or the highest point to the point of its projection? What's the height? What's the height there?
20 meters.
So that is
Meters.
20. Yes, 20 meters. So when you put that into the equation, you have 400. And the square root of 400 is equal to 20 meters per second. So this relation would also give you the same value of velocity at that instant. Bushra, Abba, Lizzie, Gloria, Amma, are you all fine?
Yes, please.
Yes, please.
Oh, okay. Please, if you are writing, quickly do so because I want to use that part of the board. Okay, then the last question, E. E says the velocity V3 just before the ball hits the ground and the total time of flight T3 at this instant. So we are first looking for the velocity V3 just before the ball hits the ground. Then we determine the time of flight. So the velocity V3 just before the ball hits the ground. And here there is this further explanation just before, because the moment the ball hits the ground, the body has come to a stop and its final velocity is 0. So we are looking for the velocity few seconds before it hits the ground. Yaba, are you okay?
Yes, please.
How do we get that? Using V squared is equal to U squared plus 2JH. Using this, I want to bring it closer so we can have a better shot. Okay. Using this equation, you know, when the body is falling, free falling from the maximum height, okay, its initial velocity is 0. So straight away, U is 0. But this time, we are considering the body falling from the maximum height and then its associated velocity just before it hits the ground. So we are dealing with the height H max plus the height of the tower. So H, the H here becomes H max plus the height of the tower 40. Because the body is falling from up here and we are looking at the velocity just before it hits the ground. So that's the total height or distance covered by the body. Therefore, the total distance becomes 20 plus 40, giving us 60 meters. Okay, so using V squared is equal to U is 0. We have 2 times 10 by the total height, which is 60. Okay, this gives us 1200. Therefore, V becomes the square root of 1200. And this is what's the square root of this? See, this is 12. I'm listening. Those of you with calculator, quickly point that and give me the final answer. Come again. Come again. Oh, Gloria, Lizzie, that,
3.
give me that in decimal. Give me that in decimal.
34.64.
34.64.
Okay, meter per second. So that's the velocity just before the ball hits. Another way, we can determine this using a different way, and that is this. You see, class, what is the velocity of the body from the maximum height up to the point where the body is initially thrown? What's the velocity there? What's the velocity there? From the maximum height to this point. Go ahead. Whoever is ready should go ahead. Don't time wasting.
20 meters per second.
Go. So the velocity here is 20 meters per second. Now we want the velocity just before it hits the ground becomes the final, which we don't know. But we have this height of the tower. So if we could get the velocity from here to here, we can just add it to the 20 to give us the total velocity just before the body hits the ground. Please, are we fine with the explanation?
No,
Are we?
please.
Look, another way to get the same answer, 34.64 meters per second. You see, we have the velocity from the maximum height to this level, which is 20, right? So if we could get the velocity from this level just before it hits the ground, we simply add it to the 20 to give us the total velocity just before the body hits the ground, and it should be the same as what we've had, right? So using v squared is equal to u squared plus 2a, gh or s. We are looking for the final velocity, v squared. We know the initial velocity here to be 20. So 20 squared plus 2 times 10 by, what is the height from here to the ground? What's the height from this point to the ground?
40
Come again.
40 meters.
Go 40. So we have 20 squared. Okay, 20 squared plus, this is 800, and 20 squared is 400 plus 800, giving us 1,200. And this will, when we take the square root of this, it will give us the same result as we've had. So that's another way to look at it. Because we have this, we just use this as u. Determine the final, which we don't know, by considering the signs, and we'll get the same answer as what you've had. Please, any question? All right. Now the time of flight. And the time of flight is the total time taken for the whole flight from start to finish. I want to use the other side of the board, so please, I want to adjust the screen. Oh, you are not done copying what is at the left at the middle.
No, please.
Then let me give you some seconds to finish. I'm waiting. Do we continue? All right, so the time of flight. 2 ways. The first method is that we know the time from the point of throw. We know the time from this point to the maximum height. And that is what?
2 seconds.
That is what?
2 seconds.
2 seconds. Now, if we could get the time from the maximum height just to where the body just hits the ground, okay, we are good to go. We add. Once we have this, we add it to the time from here to the ground, and we have the time of flight. Please, isn't it?
Yes.
So let's treat this first situation. I want to adjust the screen, so all right. Let's first determine the time taken for the body to move from the maximum height to the ground. So using S is equal to UT plus half JT squared. Or, okay, we can use this, or since you are interested in time, we can also use V is equal to U plus GT. Okay. And we have to get the same thing. Okay. Please, we are looking for this height from, let me clarify. Let me clear all this side and then call this height from the maximum height to this level to be capital H. So it means that in our formula, we actually have capital H is equal to UT plus half JT squared, right? Now, what is capital H? Class, what is capital H? That height from the maximum height to the ground. What is that? What's that value?
The total height.
So what will be the magnitude of that total height?
60 meters.
60 meters.
Yes, that's 60. So 60 is equal to free fall. When the body is dropping back, okay, it's free fall. U is 0. So we have 60 is equal to half times J, which is 10, times T squared. Therefore, we have 12, okay, is equal to T squared. Let me know, John.